recording. Okay, I'm doing a recording. I'm going to go over number 35 from the 2.4 homework. I probably should have labeled that. Oh, I got lucky. There we go. Let me rotate the image. Okay, so here you're asked to find the equation for each tangent to the curve that has a slope of -1, and then the normal has a slope. Okay, well, let's start with this one first. So 1 over, so you're taking the limit as h approaches 0 of 1, oh, my stylus is dead. Awesome, now I need to charge it. Here we go. So again, I'm doing a recording on the homework here. So 1 over, you're going to put a plus h minus 1 over a minus 1 over h. Remember, the formula is this, and that's you're going to set that equal to -1, by the way. So the formula is this. It's the limit as h approaches 0 of f of a plus h minus f of a all over h. That gives you a numerical value for the derivative. Well, we need to solve for a, and so f of a is going to be 1 over a minus 1. F of a plus h is 1 over a plus h minus 1. And the whole thing has to equal -1. So this one's going to be kind of a doozy. You'll have to find the LCD first, which is not fun, but the LCD for all this is going to be this. So you're going to have to multiply this by a plus h minus 1 and multiply this by a minus 1. Yeah, fun, right? If you do that correctly, the top becomes a minus 1 minus parentheses a plus h minus 1 all over a minus 1 times a plus h minus 1. And you got to divide the whole thing by h, which is h over 1. And it's the limit as h approaches 0. Now, fortunately, a lot of things will cancel. If you start that minus correctly, you'll have a minus a. You'll have -1 plus 1, which will cancel, so you get negative h up top. Negative h up top, again, a minus 1, a plus h minus 1, times 1 over h. Those cancel. You get -1 over a minus 1, a plus h minus 1, the limit as h approaches 0. Now you plug in 0, and you should get -1 over a minus 1 squared. And you got to set that equal to -1. Then you got to solve for a after that. Becomes algebra at that point. I'll do the algebra off to the side here. -1 equals negative a minus 1 squared. That's a minus 1 times a minus 1. Negatives actually cancel, so 1 equals a squared minus 2a plus 1. The ones cancel again. Factor out a equals 0 or 2. That's how you do part A. And then find the equation for the tangent. Well, at x equals 0, y is going to be -1, and at x equals 2, y is going to be 1. So you do y minus y1, m times x minus x1. You work, and then you just throw in the slopes and the points where they're a tangent, or the coordinates of the points where they're the tangent. For the normal, you do the same thing, but you just set equal to 1. But actually, it's the same thing. Actually, part B is the same as part A. Because now you're doing it as a normal. So if you want the normal to have a slope of 1, that means that the original tangent was -1. So A and B are the same thing. Because the normal, remember, this is for a tangent line, this formula, not for a normal line. So you got to take the normal slope and do the negative reciprocal. What's the negative reciprocal of 1? -1. We already did it in part A. So part B and part A are the same thing. Because another question, we do have to end class, is 10:10. Why do you use as a variable for some limits but x? So Catherine, so yeah, that's a great question. So whenever we're given the numerical value of a derivative, we're going to use the one that has a in it. Whenever it's asked, just find me what f prime of x is. We have to find this. So you want as an expression, then you have to replace these a's here with x's. That's the difference between the two. Okay, so watch a video, give the textbook problems a shot. We'll probably some more time homework review next time, because I think we need to kind of reinforce 3.1 just a little bit more before we move on to 3.2. So I think that's that. I will definitely do review the test questions as a video next class. In case, or maybe I might do a separate video if that makes sense. That might be a little easier actually. So you guys could watch that. And yeah, and if anyone wants to stick around for a few minutes, that's totally fine. But you guys are free to go. Let me stop.